The next talk is from Florian Forster, and he's talking about the collect-D threshold plugin and Icinga.
That's right. Welcome, everyone. Thank you for coming to my talk today. As I've already been introduced, my name is Florian Forster. Many people know me by my nickname Octo. I've been doing open source work since about 2001, and I started the collect-D project in 2005. I'm going to talk today about a very, very brief introduction about collect-D. I just assume that people who are interested in the threshold plugin in particular know what the daemon is doing roughly. And then I'm going to talk about a not that well-known kind of a stepchild of collect-D. It's good enough for some use cases, but I will point to more sophisticated solutions where that is appropriate. These stepchilds are thresholds. I'm kind of hearing myself now. And alerting. So with that, let's dive into collect-D. Collect-D is a daemon that collects system and application level metrics. It has facilities to kind of change these metrics, mangle them in a way, and then transport them to a central server, and at the end of this process, store it somewhere. It doesn't usually read metrics from a database and do stuff with it. That is left to other tools. I just was in the other room at the ElkStack talk, so ElkStack is usually a good candidate for this sort of stuff. Other options are Graphite and InfluxDB and so on and so forth. It's open source. The vast majority by now is MIT licensed, and the rest is still GPL licensed. We're kind of in a license switch that I doubt will ever complete completely, but it's open source. It is platform independent in the way that it tries to stick with POSIX for the core daemon and only dive into operating system specific stuff where that's absolutely necessary to get operating system metrics. It's not platform independent in the way that it would run on Windows. There's a commercial product that can do this. Collect-D itself runs on POSIX systems. So Linux, Solaris, BSD, AIX are all supported and work great. Collect-D uses an agent-based approach to monitoring, meaning that collect-D is supposed to run on every single machine. It's collecting metrics locally and then sends them off to a centralized service if that is desired. It doesn't have to, but that's the most common setup. It has a plugin infrastructure so that the core daemon itself is very small, very portable, very, very lightweight, and all the heavy lifting is done in plugins. And the metrics you get and the performance and the behavior of the daemon very much depends on the plugins you load and how you configure these plugins. You can write your own plugins in a variety of languages. The daemon itself is written in C. Most of the plugins that come with the daemon are written in C. You don't have to write C if you don't like writing C, and I assume that there are many sysadmins in the audience. Sysadmins tend to prefer scripting languages. We have language bindings for Perl, Python, and Java, if you want to call that a scripting language. And I'm not a huge fan of Java, but it has its uses. And I'm currently in the process of implementing support for Go so that you can compile Go code and load that as a shared object natively into collect-D. You can also execute shell scripts or any other executable binary that you might have via the exec plugin, and that will then do whatever you want it to do and reports back a very, very simple line-based protocol to the daemon. Right now, collect-D has close to 100 read plugins that read everything from your garden variety system metrics, CPU, memory, disk, load, you name it, over application metrics, Apache, MySQL, Zookeeper, a huge slew of applications, And then there are the other category, weird one-offs, very generic plugins like the SNMP plugins, interesting hardware, communication plugins such as MQTT, and so on and so forth. On the other hand, there are output plugins that write data to somewhere. Again, MQTT can be used to read values from one host and then write it to another host. More traditional output plugins would be Graphite and RD tool, writing to Graphite and RD tool respectively, Riemann, MongoDB. The HTTP one is quite interesting down here because it's used by many of these third-party providers that provide metric storage for you. So they provide an HTTP endpoint, you send post requests to it, and they do their magic and create graphs for you and whatnot. So that has seen a lot of love. This is a very, very bare-bones, simple configuration for Colleague D. On the left-hand side, you see two input plugins being loaded, or three, actually, sorry. The CPU and memory plugins, which don't need any additional configuration, and the DF plugin, which reads the amount of free and used disk space on partitions. On the right-hand side, you see an output plugin. I've chosen the network plugin in this case, which can send data over the network. It's using a binary protocol on UDP. It's quite efficient. It's quite small packets, hold a lot of data. And there is a number of applications that implement support for this protocol. One of them is InfluxDB, and there's a talk tomorrow at 9:30 in this room that will talk about InfluxDB and Grafana. And the other one would be Prometheus. There's a log later tomorrow that will talk about Prometheus. So both of these can ingest this network protocol and do more stuff with it. And of course, Colleague D itself also can use the network plugin to read values to form arbitrarily complex hierarchies. So that's all I have on Colleague D itself. As I said, a very brief introduction. Are there any questions to this point? All right, then let's talk about the thresholds. The thresholds in Colleague D are implemented as a separate plugin. As I said, the vast amount of the heavy lifting is done in plugins. The thresholds used to be implemented right in the core daemon, and eventually we pulled them out into a separate plugin because we felt that the core daemon should focus on what it's doing best, which is collecting metrics and not doing threshold checking. When it determines based on these thresholds that something noteworthy is happening, this threshold plugin is creating what we call a notification, which you might call it an alert. But since this notification can also have a severity of OK, we named it notification back in the day. There are three of these severities. Failure, warning, and OK, which correspond to critical, warning, and OK, I think, in Icinga. Pretty straightforward at this point. This is a schematic view of how this would be wired up within Colleague D. So you have the metric generation side on the left with CPU, disk, and memory. They all report their metrics to the core daemon, and the core daemon then fans these metrics out to A, the network plugin up here, which then sends it somewhere upstream, and B, to the threshold plugin, which doesn't actually store the metric anywhere. It's just doing the checking and eventually creating an alert. What you have to do to use the threshold plugin is A, you have to load the plugin. You have to configure your thresholds. This is probably the bulk of the work you have to be doing to get this going. And then ensure that something meaningful happens with these generated notifications. That's going to be the third part of this talk about alarms or alerting. So to load the plugin, all you have to do is add this load plugin line to the configuration, and afterwards you have to configure the actual thresholds. We're going to stick with a very simple example. We are going to assume that there is a temperature, whatever that might be. Let's say temperature inside a rack in a data center. And if that temperature exceeds 40 degrees Celsius in our case, then we're going to generate a warning. That's what this line is supposed to say. Metrics must be selected by a type. So you can select metrics with essentially all the parts that make up the unique name of a metric in colleague D, but the type has to be a part of the selection. The reasoning being that this way the lookup is faster, so a very implementation-specific requirement, but also without a type, without knowing what that value is that you have, defining any sort of threshold doesn't make all that much sense. So the one threshold you have for temperature does not necessarily apply to, I don't know, fan speed, for example. You can use, as I said, the other identifying parts as well, the host, plugin, plugin instance, type instance. The type is required, though, to get this going. So this is how this would look in a different scenario where you would select only the I/O weight percentage of the CPU of a fictional database server, for example. If that would exceed 40% in this case, then also a warning would be generated. But that's just to show how you can select by host, how you can select by a plugin, and then this is the type instance of the I/O weight metric that the CPU plugin produces. There are 4 thresholds that you can configure. Warning min and failure min specify the lower bound of the accepted range, and warning max and failure max specify the upper bound. So to visualize this a little bit, assuming this is the range of all values you have, and it's supposed to be a green box, but let's say this is a green box. This is your acceptable range of values. Everything in here is fine. Then you would say warning min and warning max on the lower and upper bound of these values, and as soon as your metric exceeds this acceptable bound, a warning is generated. If you want to use failure in addition to warning, you would set failure min and failure max on the lower and upper bound of this warning range, and everything falling outside of that would be a failure. As you have seen in the configuration example, I only specified a single one. I only specified the warning max in my example. If you don't specify the other ones, that boundary simply doesn't exist. So if you leave off warning min, for example, but specify failure min, there would be a hard boundary between an OK value and a failure, and nothing in between. So you can leave anything off if you're not interested in this. And in particular, you often have values that exceed a certain threshold at some point, but you're not at all concerned about the lower bound. If it's 0 and it can't be smaller than 0, you don't really have to care about this. So when we set up thresholds, or at least when I set up thresholds, this is usually what I have in mind. You know, a steady growing curve at some arbitrary point in time, we are going to have a problem. And I'm very sorry, this is hard to see, but there's supposed to be a line between here, and the one point is good, and the next point is bad. So at this point, we are going to produce a warning. Depending on the tooling you have later on, it might also make sense to, oh, sorry, I skipped ahead a bit. So the way this works is as you have a supposedly green field down here, you have a yellow field in the middle, which is supposed to be the warning range, and a red field on the top, which is supposed to be the failure range. Every time that the curve passes from one field into the other, every time a state change occurs, colleague D is going to produce a notification. So here we're passing from OK into warning, and colleague D will emit a warning notification. Here we're going back from the warning field, warning range into the OK range, which means an OK notification will be emitted. Then it races again into warning and later into the failure range, so a warning and later a failure notification will be emitted. And then the way back, most notably when it used to be a failure and it's going back down, this is where you will get another warning. So if you always keep the latest severity in memory or wherever, you will know the latest state. So a failure followed by a warning means the failure scenario is no longer the case, and it has degraded or it has improved into a mere warning, and eventually, hopefully, an OK notification. So depending on your tooling, this is what I was alluding to earlier, it may be necessary to have a continuous stream of warnings coming in. So instead of a warning at the state change, you want to have a warning as long as your problem persists. This persist true setting is achieving exactly this. So by setting it to true, as soon as you wander into the warning range, you will get a warning with every sample that exceeds your threshold. Yes, this is very spammy. You don't want to pass this on to pagers or emails or whatnot. You can try, but somebody will fix this very, very soon, I hope.
Then it works.
Yes, it's a self-regulating system, definitely. Also, depending on your setup, it might be useful to have the same behavior for the OK notifications. That may mean that you will get a huge number of notifications. If every single metric you have, and the vast majority of them is hopefully OK, produces an OK notification, you have to be aware that this is happening and your system has to cope with this. But there are good reasons to do this. So with persist OK, this behavior is expanded so that it covers OK cases. So in this case, every single check will result in a notification, and your tooling downstream can make use of this, for example, by warning you that something didn't show up in a while, for instance. In the real world, however, the data is not always as clean as the previous graph. So what we've seen earlier might have been, a rack exceeding its target temperature, and that is like an exponential fitting curve, and that is very nice, and it's really heartwarming to see in a graph that something is really nice and slowly and steady and textbook. But the vast majority of graphs is not textbook. The vast majority of graphs is something like this. And as Murphy has it, your threshold is going to be there. Anybody here who has never observed a behavior like this, where, hey, I got a warning. Never mind, no warning. Help, it's happening again. Whew, I dodged a bullet. Why does this keep happening? And eventually you're losing interest, right? This is not a good state to be in. This is not something you want happening. I'm guessing this is happening a lot with network people, so I think they have the name flapping for this, and I'm also thinking that Icinga has some way to mitigate this. The first approach we had is add a hysteresis. So instead of a hard threshold line, you have kind of a, okay, this is how you define it. This is how you configure a hysteresis in colleague D's threshold plugin. In addition to warning max 4, you add hysteresis 5. And what that means is you now have a warning range up here in kind of a maybe warning range in the middle. So the way this works is this maybe range behaves differently depending on the previous state. If you are in an OK state, you have to exceed the upper limit in order for your warning to be emitted. And if you are in a warning state, you have to be below the lower limit for the OK notification to be emitted. So in this example, the 40 line would be right in the middle, and this band would be 10 wide, 5 to the top and 5 to the bottom. So you would have a 10-degree temperature band in which if you're above 45 degrees, you will get a warning, and only if you're below 35 degrees, then the OK notification will happen. And if it is kind of 40 and flapping around and never going above or below 40, really, you're not going to get any notification. Whether you're left in the warning state or you're left in the OK state depends on what the temperature was previously. However, this solves the problem for some cases where you're close to the threshold, and you may occasionally be very close and maybe even a little bit above, but you don't really care. But another common pattern is this, and this cannot be helped with the hysteresis curve. This is a very common pattern with latency. It's fine, it's fine, it's fine, then, I don't know, some backup is happening or an abusive user or something other bad. You get a couple of bad samples, and before somebody can do anything meaningful, it's back to normal and nobody should care anymore. Or at least nobody has to be paged for this and woken up because it's gone already, and if it's a recurring pattern, you have to work on this in your daytime job anyways. And it's not something you will fix in 4 in the morning. Yeah, so you will still get a warning in this case, or a notification in this case, even though it probably shouldn't be a notification in the first place. So the second approach we implemented is that it will only trigger a notification if the same state happens multiple times in a row. The configuration option it's not the best name in the world. It's called hits. So in this case, if it's a warning 6 times in a row, then we will actually send a warning. So the way this works is everything's fine down here, and then we get the first outlier up here. And essentially, it starts counting. Well, 1 potato, 2 potato, 3 potato. Well, that wasn't enough. That wasn't 6, so I'm going to stick with everything is all right. So I'm guessing my point here is this is still probably not the best behavior of a system, and this is probably something you want to look into eventually, but this is not something to wake people up for. The time delay between these dots, by the way, in colleague D is typically 10 seconds. So having something break 6 times in a row means it's broken for a minute. That's an okay time to wait. Actually, one might argue that this is still way too trigger happy. So I was talking about colleague D being more or less stateless, and if you start a new server somewhere and send metrics to the central server, it will happily accept that. And if the server goes away again, or the network breaks or something, then the metrics will not arrive, and that is okay too. So colleague D doesn't care, but you might. So in order to work around this, the threshold plugin has a concept of interesting metrics. You can define metrics that are interesting just by essentially setting interesting to true. And what that means is I'm actually interested in this metric. I need to know when this metric does not exist anymore. And when this metric goes away, when this metric is not received for the timeout, there's a timeout setting that defines how often a metric has to, the time between, okay, every metric has an interval, which is the time between updates, or the expected time between updates. And it's in the default settings, it's expected that within twice this interval, I will receive an update. So instead of 10 seconds, 20 seconds. And if I don't receive an update in 20 seconds, then this interesting true will emit the value is missing failure notification that you can subscribe to, or that you can use in your scripts. This is all I had about the threshold plugin. Yes. We need a microphone, I think. If it's short, I can also repeat your question.
Should do that, please.
Yeah, for the second type, the bursty type where you implemented the hits counter, did you think about doing it with moving weighted averages?
No, we didn't think about weighted averages. In retrospect, what I probably would have implemented instead is something along the lines of 6 out of 10 or so. Instead of requiring 6 consecutive failures, that out of the 10 last samples, 6 must be failures.
Yeah, that's exactly what I mean.
Oh, that's what you mean.
It's called moving weighted averages, not just weighted averages, but moving. So you have like a bucket, like 10 measurements, and then the last ones are weighted higher than the earlier ones.
Okay, I think we're talking across purposes still. So the first step is to look at your threshold and determine is this okay or not. Essentially, it's a yes or no question, or tri-state if you want to say okay, warning and failure. And then you have a short history of, let's say, 10 last states, and a moving average would actually take the measured metric, the measured value, and say, like in the last 20 samples, I had an average CPU I/O weight of 37.5% or something like this. There are some ways in that direction that you can do with the aggregation plugin, though not time-wise. No, forget what I said. No, moving average over the actual metric values is not possible. But in retrospect, what I would have done, probably what would have been better, I guess, is to have like a window, like in the past 10 or so of my samples were bad, I'm looking at the last 10 states, and if 6 of the last 10 were bad, then I'm going to alert. It's similar, but not quite the same. Does it kind of make sense? Anybody understanding what I'm trying to say? I'm a bit at a loss for words, I'm afraid.
The problem is the recovery.
The problem is recovery. How do you mean this?
One moment,
Ten,
please.
6 of 10. If you look 6 of 10 states, when do you do the recovery? They're okay.
So eventually, you're going to have 5 out of 10 are bad. Or you have 10 good states, and then it starts failing, and this last 10 states start filling up. It's moving forward, and you have 1 bad out of 10, and 2, and 3, and eventually 6, and then you start firing. And the normal progression, the expected behavior would then be that it's still broken for a while longer. Eventually you have 10 out of 10 failing, and eventually it's somebody gets around to fix it, or it fixes it itself, or whatever happens, and it's happy again. And then the reverse process starts. At first, the first one is still, it's okay, but you still have 9 failing in the buffer. And then it starts filling up with okay until eventually it goes underneath the 6 failing out of the 10.
It's good, yes.
But the behavior that you have something failing and okay, and failing and okay, and failing twice and then okay, and so on, that this is no longer as jumpy as it used to be.
As I have the microphone, I want to have another question.
Sure.
About you sending all the okays or all the failures. And the one you can set like, say, no, not this one.
This one?
No, go back. This one.
This one, yeah.
Yes, okay. Did you think about some sort of, instead of sending all of them, sending like a heartbeat? Just a heartbeat?
What would you set the heartbeat setting to?
To some seconds, some time limit?
But these metrics are coming every 10 seconds. So
Yeah, but instead of sending every 10 seconds,
okay.
It's like a heartbeat, this one, okay? So you're sending every 10 seconds. I say I don't want it every 10 seconds. It's enough for me if you send it one time a minute or something like that.
So downsampling these OK notifications
Exactly.
effective, because there's not a huge difference between a heartbeat and an OK notification. The OK notification, I think, still transports the current metric value in the payload, in the actual text. So it's a bit more useful for, let's say, a status display in Icinga or something.
Now I think if someone is waiting for these messages behind, otherwise it won't make sense if you send them, if nothing is waiting for them, okay? And for the system waiting for them, instead of sending every time, you're always sending the status changes, obviously. And then you some heartbeat or some time frequency, you just said, I'm still here, so I'm still sending.
Oh, you mean a heartbeat of the colleague daemon itself?
Exactly.
No, we don't have that. It should be fairly easy to implement this if anybody's interested. Sounds like a good starter project into the open source project. So if anybody's interested, I'm very happy to work with you, but we don't have this right now. Are there any more questions regarding the thresholds? I was not nearly confusing enough. All right. A comment. All right. Then let's dive into alerting. Alerting is essentially taking these notifications and doing something meaningful with it. As I said in the introduction, this is not the main focus of Colleague D, and there's some support, but it's kind of like an unloved stepchild, and it's often implemented as an afterthought. So many plugins that maybe should support the handling of notifications don't. My best example is the write HTTP plugin that sends out the HTTP post request, should probably send out notifications to, but currently doesn't. Again, patches are very welcome. Plugins that do support notifications are most notably the exec plugin. The exec plugin can execute an arbitrary script with the notification on its standard input, and I'm going to show this on the next slide. The network plugin can take notifications and send these notifications to a central host, for example. So you can do a threshold checking, which unfortunately in the current implementation is quite CPU intensive. Mostly the looking up the configured thresholds. So you can do the threshold checking locally on every machine that the agent is running on, and then forward these generated notifications to your central server.
Sorry, can you please put the microphone a little bit nearer to your mouth, so it's louder.
I totally feel like a dork, but better?
Is it better?
Better, anybody?
Okay,
Perfect.
thank you.
I see a thumbs up.
Okay,
Right.
thank you.
Okay, let me oil my voice. All right, the log file and syslog plugin can write notifications to the log file and syslog respectively, which is probably not that surprising. The write Riemann and write Sensu plugins can also forward notifications. And I'm probably missing 2 or 3, but it's not an overwhelming number that can deal with this. This is how the exec plugin is configured. It's fairly straightforward. The only caveat, I guess, is that you have to provide a username here. This is because to get some metrics, colleague D sometimes or often runs as root, and we simply downright refuse to execute scripts as root, as colleague D. So you have to provide a user here. But apart from this, you provide the path to something that is executable. You can add additional arguments here as strings if you require this. And then whenever it receives a notification, it just goes off and executes that script. This is roughly what the script gets on standard input. There's a severity and a time. The time is an Unix epochs. You get the host plugin type, eventually type instance information in a header that is similar to HTTP. We're not following any standard per se. We expect people to just, break at a column or something. So there's no fancy multi-line header fields and all that sort of rusty corners of HTTP that serve no purpose except for exploit every 2 years or so. But it's a fairly straightforward, simple header format to parse, I hope. And then eventually there's a blank line, and then this is just human-readable plain text. In case of the threshold plugin, it looks somewhat like this. So it will tell you that the metric value is currently 42, and that this is above whatever threshold is configured. And if you read this in correctly, you can forward this to whatever you need to forward this to. In addition to these more generic plugins I showed on the previous slide, there are also specialized notification plugins that do nothing except working with notifications. The 2 that we have right now are Notify Desktop, which is using the desktop notification specification to, pop up these little balloons that say, hey, something is broken. Not the most useful for any serious setup, I'm afraid, but it was fun to implement at the time. More interesting, I guess, is Notify Email, which does exactly what you expect it to do. It sends an email. You configure something like this. You load it. You set a from address and 1 or more recipients. Maybe some configuration is required to send email via an SMTP server, and there you go. That's all you need to send emails and pester your colleagues. Last year, I ended my talk with a slide, what's next, and proposed that maybe for the future we could send notifications as passive checks to Icinga. And since I have written a new plugin called Notify Nagios, which is currently in review, and I hope that one day we'll be able to do exactly this. It's currently writing service checks to Icinga's, what is it called, command file. And hopefully, eventually, Icinga will pick it up from there and do stuff with these notifications. Since I don't use Icinga personally, I would be very happy if people would step forward and help with this work. I could, for example, see that host checks might be a valuable addition to this, so that the code essentially sees that I received a metric from this host, so apparently it's up. So every, I don't know, 60 seconds or so, I'm emitting a host check thing. But just a thought. I have no idea. I don't know what I'm doing. That's all I have. I'm happy to take any questions. Thank you.
We've got 20 minutes left for questions. Here's one.
Concerning thresholds, just taking a quick look at the documentation, you've got a collect the Nagios plugin for active pulling.
Yes. The way this works, you said your question how it works?
The question aims for, is this plugin aware of the thresholds you just talked about?
No.
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 Okay.
The way this plugin works is that it uses a Unix domain socket that the daemon opens to get the last metric value. And then, as you do with many, many other plugins, it has like a -C and a -W option where you specify the thresholds on the command line. And then it will check the last value it got against these thresholds and exit with the appropriate exit status.
Okay. Are there any plans to add this? The awareness of the threshold plugin? Not really. Okay.
No, we don't have any plans. I guess I jumped a step ahead and thought about if it was possible with the current infrastructure. It might not be that easy because there's no state kept on notifications. They're just passed on, and it's hard for an external tool such as the collecting Nagios binary to actually get any information about current or past notifications.
Okay. Thank you.
Of course. Over there.
If you do need another thing for next year, Icinga 2 has a nice network API. And
right.
so perhaps notify Icinga 2 with this network API for a cluster setup would be useful.
That's very valuable to know because right now it's not yet merged, and backwards incompatible changes are easy to make at this point.
Okay, here.
I have a question if there's something regarding trending. So, for example, you have, let's just take disk space utilization over a period of time. You have different samples. Let's just say your threshold, your maximum threshold is, I don't know, 10% disk space remaining. But you kind of notice that between your samples, all of a sudden there's a huge increase in the deviation. Is there something around that or to notify on that?
No, there's nothing like this currently in Colleague D, and I don't think that Colleague D would be the right place to solve this issue. There are other tools that can do stuff like this very well. Riemann, for example, is probably notorious for being hard to configure, given that the configuration language is Clojure. But it is very, very powerful, and it can certainly do stuff like this. Another tool that's also maybe a bit more advanced to configure and set up correctly, but which is certainly able to do stuff like this, would be Prometheus. So if you're interested in more complex metric computations, I would suggest you see that talk tomorrow. That's probably going to be very interesting in that regard. I hope so. I was talking to someone this morning.
Thank you.
Sure.
Any more questions at this moment? No, I don't see any hand. So I think we're finished. Thank you, Florian, for your talk.
Welcome. Thank you.